Hi, so in this video I'm going to talk a little bit about this library called Python Benedict, which I actually ran across kind of by accident recently, and it's a really interesting library, so I wanted to show you some of the things that it can do. So as usual, all the code is available in the GitHub repo, which is linked below the video, and if you want to support this channel, please subscribe, please like the video if you liked it, of course. Leave a comment. All this really helps this channel and it kind of motivates me to make more videos like this one. All right, so with the advertising out of the way, let's continue. So the library is called Python Benedict. There's a link to the library itself in the notebook, and basically it's kind of a more advanced kind of dictionary, and I assume it comes from the Italian or the Latin bene, which I think means well or good, and dict must be dictionary, and it was written by an Italian developer, so I'm assuming that's what that name means, Benedict. Anyway, to install the full library, you'll have to do a pip install python benedict all, and again, that's also in the notebook. I'll just paste it here so we have it. But this is the command that you can use if you're using pip for installing your libraries. So this installs the full library. It is possible to only install a subset of the library depending on your needs. And that actually relates to the fact that this library can retrieve dictionary-like objects from various sources like CSV, JSON, HTTP requests, even S3, and a few others as well. So the library does look to be under active development. It's got 1.3 thousand stars, so it's well liked, and it looks like even though it's a single developer, he is supporting it, and so I would probably, really consider that when I want to bring that into, let's say, a production kind of application. I think this one is probably pretty safe, but your mileage may vary, so, take that into consideration. All right, so let's jump right in. We're going to cover the following features. We're going to cover how to instantiate Benedict objects from dictionaries, HTTP requests, and JSON. It has other options too, but we'll cover those three here. Then we'll look at how we can access and mutate these kind of, advanced dictionary Benedict objects, which are essentially dict subclasses. So we'll see that Benedicts are actually Python dictionaries that have just been extended in a variety of ways. We'll look at how to make them immutable. You can't do that with dictionaries. You can use a mapping proxy, but dictionaries in Python are mutable. You can actually make these Benedicts immutable. And then we'll take a look at some of the more advanced methods on this thing, which is traversal and filtering methods. And this really comes very handy when you have things like nested dictionaries and you want to traverse, let's say, every single nested subkey in a dictionary. Well, it's very, very easy to do that with this library. And that's what really, kind of caught my attention. It wasn't so much that it can read from JSON or HTTP requests. I mean, we've got Pydantic for that. We have the JSON module. There's other ways that we can do it. But the query kind of tools that you have are really, really good. So let's start by defining a nested dictionary. I'm just going to copy paste the code from the notebook so we save some typing. So here's a rectangle. It's a dictionary. It has these keys: dimensions, center, and colors. You can see dimensions is itself a dictionary with 2 keys. Center is a dictionary with 2 keys. Colors has 2 keys, edge and interior, which themselves are dictionaries as well. So you can see that we have up to 3 levels. Well, 1, 2, 3 levels of nesting, right? For the deepest nesting in this dictionary. Now, let's say that we want to get the alpha value for the interior. So I want to retrieve this from the dictionary. Well, if we're using Python, this is how we would go about it. Of course, you could use the get method as well. If you're not sure if the key exists, you can use that. But let's assume that the keys do exist. So this is how we would pick up the alpha value, right? We would just execute that and we get 50. So now let's use Python Benedict to do the same thing. And this gives us a very handy dot notation. So the first thing I'm going to do is I'm going to make a Benedict from the regular dictionary. So this is one of the ways that we can create these Benedict objects, is by passing it a Python dictionary. So after we import the Benedict library, we can create this Benedict object. If we look at type rectangle, you'll see that it is a Benedict object. And by the way, we can ask if the rectangle is an instance of dict, and the answer to that is true. Remember what I was telling you is that Benedict extends the Python built-in dict. All right, let's go ahead and print now this Benedict object. Let's see what the string representation looks like. And it looks like just a regular dictionary. So it's now possible to access keys in the nested dictionary in a variety of ways with this library. The simplest is probably just to use dot notation. So we can say rect dot colors, because that's what we want. We want colors, right? And this is the problem. This is why I don't like making my code so large. It's difficult to get context. So we're looking for rectangle colors dot interior dot, and it does not do auto completion, right? So this thing doesn't know what's going to come, right, in terms of keys. So you're going to have to type it out. So we have rect colors interior alpha, and you see that we were able to access this key by using dot notation, which is a lot nicer than this syntax over here. Now we can actually also use this notation to set values in the Benedict object. Let's say that we want to set the value. We want to change the 50, and let's say we want to make it equal to 60. Well, we just set that equal to 60. We execute, and then if we read the value again, you'll see that it is now 60. Now this was the Benedict object. We created the Benedict object by passing it a regular Python dictionary, which was which one? It was this one here called rectangle. Let's see what happened to rectangle. And you can see that the value for alpha also changed here. So basically this Benedict, when we passed in the Python dictionary, is still using that dictionary as its kind of base. So any mutations you make to Benedict is going to be reflected in the dictionary, in the original dictionary. Now, if you don't want that, you could always create a deep copy, right, of your Python dict, the original dict, and then use that instead if you want to kind of disassociate the two objects. Now, we saw that this rect object, this Benedict object, is in fact an instance of a dictionary, which means that it has all the dictionary properties as well. So if you want to still access, let's say, rectangle is the regular dictionary, rect is the Benedict dictionary, right? If we look at type, just to convince ourselves, okay? So it still supports, notation using the square brackets. So we can say colors. Well, actually, I'm just going to copy paste it from what I had over here, right? So I'm just going to copy this. We'll paste it down here, and we access it the same way. So this is another way to access elements of the Benedict. And of course, you can also use that for setting the value, not just getting the value. The other interesting way that we can do that is by actually just having a string path where it's a little bit like the dot notation, but instead of actually it being code, it's just going to be a string. So this is useful, for example, if you're building your path up from somewhere else and you've got strings that you're concatenating, then instead of trying to, kind of work your way around that to try and get to the dictionary items using this kind of notation, then you can do something like this. You can take rect, and then we're going to do square bracket. But what we're going to do is we're going to pass it the string colors dot interior dot alpha, like so. And when we do that, you can see we get that value back from the dictionary. So those are kind of three ways in which we can access data in the dictionary, in the Benedict, right, using those techniques. Now, of course, this begs the question of, well, if you're using this dot notation here, right, or this dot notation over here, what happens if the key in your dictionary itself contains a dot? And that's actually going to present a problem. So let me just copy paste this data, and we can get around it somewhat, but not in every way of accessing the dictionary data. So as you can see, I have keys here that have dots in them. So I'm going to try and make now a Benedict out of this data dictionary, right? This is a data, it's a plain dictionary, I should say. And I'm going to try and make a Benedict out of it. But the keys have periods. So when we execute this, you can see that we get a value error. And it says the key should not contain the key path separator, which happens to be a dot, right? And it found a dot 1. So we can't even load the dictionary up into the Benedict. However, what Benedict allows us to do is to specify a different key path separator. So for example, I'm going to want to specify the pipe character as the path separator instead of it being the dot. Now, of course, this means that we can't use dot notation anymore, right? But we can still use the string with the dot notation, but instead of using a dot, we need to use something else. And we specify this as key path separator, and you specify whatever separator you want. So I know I don't have a pipe character in my dictionary keys, so I'm going to use that, and I'll assign it to D. Okay, so now we have this dictionary over here, this Benedict, and I cannot access things like D.A. That's fine, D.A, but I can't do D.A.A.1, right? That's just not going to work. That's incorrect syntax. So this is what I was saying, is that using this key path separator works. It allows us to still get a Benedict even though our keys have periods in them, but it doesn't give us 100% of the functionality. However, we can do this. We can say DA. Now A is the key, and then we have the pipe character for the separator. So not the dot anymore, we're using a pipe. And now we have the key as A.2, and that is going to be perfectly fine. As you can see, we get 200 back. We got this value here for this key. So it is still possible to use Benedicts if you have dots, periods in your dictionary keys. You just can't use the pure dot notation, right? D.A works because A doesn't have a dot in it, but .A dot what, right? How would you specify? You'd have to specify this, and of course, that's not going to work. Now, you could do this, right? You could say D.A and then A.1. So you can kind of use your path a little bit with the dot notation, and then you're going to have to use this. So if you wanted to go further, if there was nested, then you could do this and so on. Okay. Now lists are also supported, and as expected, we simply use kind of the index, the square bracket index, to specify the element of the list we want. Let me show you what I mean, because it's actually pretty straightforward when we see it. So here I've got a key, A_1, that is actually a list, and I want to get the element. Well, it's very simple. I'm going to make a Benedict out of it. We'll pass it data, and then we're going to say D.A_1, and I want, let's say, the last element in there. So I can just, it's referencing a list, right? It is a list, and it does work correctly. So indeed, we get that. Okay, so that's how we can access elements. And this, of course, we can get and set elements of the dictionary using the Benedict. And remember, it ties back to our original dictionary. And keep that in mind, because we're going to look at how we can query dictionaries, how we can basically run queries and filters, right, or traverse the dictionaries, our Python dictionaries. So we can start with a regular Python dictionary in our code, and then when we want to do the traversal or the filtering, we just make a Benedict out of it, and then we do the traversal or the filtering there. And then we can always go back to our original dictionary and continue with it, But since it is a dictionary, you can leave it at that. But we'll come back to that in a few minutes. So this library allows us to load the data from a variety of data sources. For example, we could specify a URL to get some JSON data back from some API. Here I'm going to use the Star Wars API. So let me go ahead and paste this code in. So you'll notice I didn't have to import the requests library. All I'm doing is I'm creating a Benedict object and I'm passing it this URL. And the key here is I'm saying the format is JSON because I'm going to get JSON back from that. So when I do this, you can see it executed. Now it's finished executing. Let's take a look at what's in Luke. And you can see we have a dictionary. It actually made the call to the API. And this worked because there was no key, right? We didn't have to specify a key. So I don't know if there's a way of using Benedict to do these API calls without with a key. So that's why I use the Star Wars API. Doesn't require a key. I personally wouldn't use Benedict this way. I would use the requests library. I would have a proper request, HTTP request. I would be able to specify timeouts. I'd be able to specify custom headers, potentially with authentication and so on. But it's nonetheless interesting to know. And of course, we can access this now since it's a Benedict. We can look at the films, right? Films is a key in here, and it happens to be a list. So we could say, well, give me the first value, like so. Or, of course, we can use the other notation. We could just use an actual string, and we put everything in the string, right? Like so. And it works exactly the same way. So I probably wouldn't use Benedict this way, but I would use it to be able to easily query, for example, my JSON data if I wasn't using something like Pydantic maybe. So let me just show you a quick example. Again, I'm just going to copy paste that from the notebook. So here, now I imported requests. So now I have complete control over this, right? I can make sure it's doing a get to a specific URL. I could include the headers. I can do a raise for status. So it's going to check to make sure that I didn't get an error level status. And then I can get the text out of that like so, right? And so this is my JSON string. Now I can use now Benedict to say Luke equals Benedict. And here, I'm not asking Benedict to make a call to the API. I'm just going to tell it, I'm going to pass you JSON data. Take that, make it into a Benedict dictionary, right? So for that, we're going to use the from JSON method. And I have to spell it right, from JSON. And now if we look at Luke, well, we have now a dictionary. And of course, the type is going to be a Benedict, right? If we do type this, then we get the Benedict. Now, of course, you could also just do it this way. You could say Luke equals Benedict, and then you can take your data.json, or data is actually what got returned right from the request. It's got a JSON method. You do that, and then you're going to get basically the same thing. You're going to get, sorry, not data, result, right? Result was what we got from the request, right? The result. Okay, so let's do that. We get the Benedict, and then if we do Luke, again, it just has the data. So, I mean, you have obviously different ways of doing all this. All right, so I want to go back now to just plain Benedicts. We're going to look at our rectangle again. So if we look at that, we saw that these objects are mutable, right? We saw how we could modify an existing object. What we didn't see is how do we add elements to the dictionary? So let's say that we want to add something. Now, what I want to do is I'm going to want to make a copy of this Benedict, essentially, that's not going to affect the original rectangle. I could do a deep copy of rectangle and then make a Benedict out of the deep copy. Or I can use the clone method that Benedict provides, which essentially is going to give us, a separate dictionary. So this rect now is no longer going to be bound to this rectangle over here through the clone method provided by the Benedict library. Now, of course, we can use standard notation. So we could say, let's say colors, and let's say edge. So we're looking at the edge, right? Colors, edge, and we don't have an alpha in here, right? For edge, we have RGB and thickness. So I'm going to add a key to here. And since Benedicts are dictionaries, we know that this is going to work perfectly fine. If we now look at rect, you can see that we have now an alpha over here for the edge. And if we look at our original rectangle, well, that hasn't changed, right? The edge still doesn't have the alpha. So as you can see, because of the clone, we didn't affect the original dictionary. And of course, we can use just regular ways of adding keys to dictionaries. But what about the other access notation? Let's go ahead and make another clone, just basically to reset this. I don't want to have the alpha in there, so we're going to start fresh. And I can just say this. I can say rect dot colors dot edge dot alpha equals 10. And so this dot notation is essentially going to see this and say, oh, the alpha key doesn't exist, put it in. And so now if we look at rect, you can see that we have that. And of course, you could also use the strings, right? So like so. So if we do this, we can say rect, and then we're going to say colors dot edge dot alpha, like so, equals 10. And you can see it worked exactly the same way. All right. So again, we can access in different ways. All right. So this is kind of the basics of how to create these Benedict objects, how you can get and set stuff, how you can even use it to access other resources. I showed you, for example, with the HTTP, I wouldn't use it that way, but it can also do CSV. It can load JSON, as we saw. It can also load from S3. There are connectors for S3. Again, I probably wouldn't use it that way. I like having control when I'm hitting external services. I don't like relying on some library kind of, a black box. I have no idea what it's doing. How do I authenticate? Okay, so I wouldn't use it that way. But it is there if you need it and if you need something quick and dirty. Okay, so now let's look at some of the really interesting aspects of this library. Some of the dictionary methods that Benedict adds on to regular Python dictionaries. So I'm going to again use the Star Wars API, but I'm going to use my own way of requesting stuff. And I'm going to ask for the people, right? And then I'm going to take this data, which is going to be the response JSON. It is going to get JSON back. And I'm going to make a Benedict out of it. And let's take a look at the contents of that. So there you go, right? We have a count, we have a next, previous, and then we have this results. And results is a list of dictionaries. If you wanted to print this nicely, by the way, a simple trick to print a dictionary nicely, because this is now a dictionary, we can say print and then JSON and we have to import the JSON library, JSON.dump string, and we're going to take whatever this people is, right, which is a dictionary. We're going to dump it to JSON, but we're going to specify an indent of 2. And of course it works here because I know this dictionary has JSON serializable data. You don't always have that when you're working with generic, with general kind of dictionaries in Python, but it is available if you know it's going to serialize correctly. Deserialize correctly. So this is kind of what the data looks like. Just there's a ton of it, right? So you see the results are dictionaries. It's a list of dictionaries with name, height, mass, hair color, skin color, eye color, and so on. So there's a bunch of data in there. So now let's look at this first thing, which is traversals. So as you can see, we've got nested dictionaries, right? We've got a dictionary, we've got results, which is a list of dictionaries. We have films, which is a list, right? And so on. So we can easily traverse each entry of the dictionary by using the traverse method. And this method needs to be provided a callable that will receive 3 arguments. The possibly nested dictionary, and within that dictionary, the key and the corresponding value. So essentially, when we traverse, every node that the traversal hits, it's going to call this function. And this function, this callable, is going to receive 3 values. It's going to receive the dictionary that's currently being looked at, which is that node, right? Or the dictionary in which the node is present, which could be the outer dictionary, or it could be a nested dictionary, right? Depending on where you are in the traversal. It will then also tell you the key and the value that it basically found. So let's go ahead and actually just do that using this data over here. So I'm going to create a process item function. It's going to receive the dictionary, it's going to receive the key, and it's going to receive the value. And I can now do whatever I need to do with that, right? As I'm traversing the nodes in this dictionary, what do I want to do with each one? Well, here I'm just going to print, and I'm going to print the key. So we're getting the key. I'm not going to print the dictionary because we'll be printing dictionaries and we'll kind of, miss what we're actually looking at in terms of the keys and values. So this is all I'm going to do for the process item. Obviously, you could do other things with it as well. And then all we need to do is we take the Benedict and we just say traverse. And then we tell it which callable to use. As it hits each node in this dictionary, call what? Call process item, and it will receive those 3 values. So let's see what happens. And I need to change this to be value. Okay. Now let's try it again. All right. So basically, this is a lot of stuff to look at because there was a lot of data in this dictionary. You can see that it received count, then next, then previous, then results, and then results was this long list over here, right? And it is indeed one of the nodes and one of the values therefore. But then it goes further. It says, oh, well, then you have item 0, right? And for item 0, you have a dictionary. And then within those dictionaries, you are going to have name, Luke Skywalker, height 172. It's iterating through that. So basically, it's going through every node. Even if the node is dictionary, that'll be the value, but then it's going to iterate through that nested dictionary or that nested list. Now here you might be wondering, well, it doesn't tell us which dictionary this is from. Well, actually it does. It's just that I'm not printing it out over here, right? We're receiving D. I'm just not printing it out. But we do know which dictionary this is actually coming from. Okay, so this is Traversal. I just wanted to show you with just data that you get back from an API how you can very easily use it. You can see I didn't really have to do anything special to do a traversal. Now let's look at another one that's implemented by Benedict, which is filtering. So we can easily filter the dictionary, and all we need to do is to use this filter method that we now have on the dictionary, and we need to pass it a predicate function. Predicate function is what? It's a function that's going to receive something, and it's going to have to return true or false, right? And this is just like the plain filter function that we have in Python. You have a predicate that you can specify to specify which elements you want to hold on to and which elements you want to discount as you're filtering. It's no different. So if you're unsure of what I mean about predicates, go and look at the Python documentation for the filter function. But anyways, we're going to take a look at an example right here. So data equals people.results. So I'm going to take that list of results, right? Instead of taking the outer dictionary, I'm going to start with just the results. We can look at the first item, and this is what it is, right? It's a dictionary, and it has name, height, mass. It has these various keys, and then some of the keys are themselves lists, and so on. Now, let's say that I want to go through data, which is the results, right? Which has these dictionaries. Each of these dictionaries has the key name. And what I want to do is I just want to filter out those name keys from all those dictionaries in that list. And then I want to see the corresponding value. So basically, I'm trying to extract the names of the people returned by this API call. Okay, so now what I want to do is I just want to get the name of the person in every one of those dictionaries, right? Data is a list of dictionaries. Each one has a name, key, and a value. I just want to get a list of that name and value, right? So if we go back and look at the original data, you'll see that we have name Luke Skywalker. Then we're going to have another one somewhere, name R2D2, and so on, right? So I want to pick that up. I want name Luke Skywalker, name R2D2, and so on. So let's go ahead and use Benedict to do that. So now I've got a list of dictionaries. The list is in the Benedict, right? Data is a list. So what I'm going to do is I'm going to iterate through that list. So I'm going to say for D in data. So for every dictionary in that list data, what do I want to do? Well, I only want to keep the elements that are going to basically satisfy some condition out of the dictionary D. So I'm going to do a filter. Now the filter requires a predicate function. So the predicate function, and I'm here just going to make a lambda. You could of course make it a regular def function too, but here it's small enough that I can just make a lambda. That predicate function will receive two values from the Benedict. It will receive the key and its corresponding value. And then you can just do whatever you want with that to indicate whether you want to retain this key value pair as you're filtering or get rid of it. In this case, I want to only keep this item if the key is called name, like so. And so when I do that, you can see that it basically iterated through every Benedict in here, because remember, data was a Benedict, so people results, which is a list of Benedicts, they therefore have this now new extension called filter to a regular Python dictionary. And we do this via this predicate function. So you can see it only kept the key value pairs in here where this function evaluated to true, which was essentially, we said, when the key was equal to name. Now, one thing to note, the filter method is not recursive. So I'll say that again. The filter method is not recursive. You cannot use it to say, well, look through all the nested dictionaries, right, in this possible, large dictionary that contains all these nested dictionaries and just gather all the keys whose names are, X. It doesn't work that way. This is not a recursive function. So the keys and the values received apply only to the top level of the object being filtered, D in this case, right? So just keep that in mind. Now for a nested approach, however, there is something available. And we can use the match method. And we can use it with a wildcard to indicate that we want any path. So the match, we can just basically match on a path. And we can use a wildcard. So what I'm going to do here, this was D. Let's type it here. Remember we have people, right? People was this large dictionary which had the results also, and so it's got, lists of dictionaries and so on. So what I'm going to want to do here is I want to say people.match. And I could just say match, let's say on count, right? So if I do this, it's going to return 82 because it found that. But this is only looking at the items directly in people. Now I could give it something else. I could say match on, let's say, results and .name, for example. So now I'm looking at results.name, but that's not exactly going to work because results is a list, right? So we do have the possibility of using a wildcard. And we can use it this way. We can say, look at every item in results and look for the name key, right? And so we get the value back. So here we're not getting the key back. We just get the values when we do the match. That's one way of doing it. A simpler way is just to say, look, I don't care if it's in results or not. As long as it's called name, I want to get it back. So in that case, I can just say people.match, and then all I need to do is just to say star.name, saying doesn't matter where it is, as long as the key is called name. I don't care where it is in this nested structure. If it's in a list or a nested dictionary, within a list, within a nested dictionary, return it. And so we get the same result, obviously, because name was only present in that list of dictionaries. So this is really, really useful when you're searching for something in a large dictionary that has nested dictionaries. You don't have to iterate through the different keys to say, well, if it's a list, then iterate through the item. If it's a dictionary, and use a recursive approach, this match here will do it. And there's other things you can do with match, so I recommend you take a look at the documentation. Now, another one that's also really interesting is this flatten method. So let me go back to the original rectangle that we had. Remember that we had this rectangle. It's a little simpler to look at the data here, right? I really wanted this large data so we could do things like match and filter and so on, so I could show you that. Here, let's go back to this one. I don't want so many keys. So this was the one that we had. And what I'm going to do is I'm going to, just like before, I'm going to make a Benedict out of rectangle, like so. And now I'm going to call rect.flatten, and let's see what we get back. So we get a dictionary back, and you can see that, and let me actually do this. Let me just say from pprint, import pprint, and let's just pretty print that dictionary. That doesn't do anything. That's why I like using JSON. Can I? Yeah, I can serialize this to JSON. So we'll use that trick that I did earlier, json.dump_s, and then we'll say indent equals 2. And need to type it right. Okay, so now we can see. So look at what it did with our original dictionary, our original rectangle. Let me go ahead and say this as well. So print JSON dump string rectangle indent equals 2, right? So this is what our original dictionary looked like. We have dimensions, then length and width. And here, what do we see? Well, you can see that there are no dictionaries nested here. Instead, it's flattened it out. We have dimensions length is 100. Dimensions width is 50. Look at this one. Colors, edge, RGB is this list, 100, 100, 0. What did we have over here? We had colors, then edge nested and RGB nested. So what it does basically is it flattens this dictionary out. And it basically makes the key kind of like a path of all the keys that where it found this particular value. And it uses this underscore to separate the path essentially that it took through the dictionary. Now, the one thing too that I found out later after I'd been using this technique over here is that Benedict actually offers you that built in. So let's go ahead and use that. So I'm going to print rect.flatten. And here I don't want, let's say, an underscore for the separator, right? That's what it does by default. You can actually override that and say, I want my separator. So separator, and I want that to be equal to, let's say, a colon, right? Now, of course, if I print that, I'm going to get, again, this flattened print. I could use the JSON dumps, or I can actually use the dump method that Benedict provides. So I'm going to get, remember, this is a dictionary, right? But we started with a Benedict. This is also a Benedict, not just the plain dictionary. And Benedict provides us this method over here. And so we get that, right? I don't have to do the JSON dump s indent equals 2. You can just use that as well if you want. So the interesting thing, as you can see, is that the separator now, like colors, edge, thickness, well, that is no longer an underscore. It's a colon, right? And if I wanted to, I could actually use a dot if I really wanted to do that. But of course, now I've got a problem. Right? Because my separator for the paths in the Benedict is a period. And here I'm trying to use the same thing. And it says, no, you can't do that. So you would have to basically create Benedict using a different kind of separator, of path separator. I showed you how to do that earlier. Then you could use dot here. Okay? So we can go back to the colon. You could do a slash, for example, up to you, kind of what you want to do. Now we can also get a list of all the key paths in our dictionary. So without the values, right? So we saw how we could do a match that would give us, all the things that we wanted on the values. Remember, we did that with a match. We got values. Now we can also actually ask Benedict to give us all the key paths in this dictionary. The key paths being what? Well, if we look at the dictionary, the original dictionary, right, we have dimensions, length, then width, and then center X, Y. So when it did the dump over here, when we did the flatten, we had dimensions length, dimensions width, center, x. Now we use this separator here. But of course, remember that with a Benedict, we can essentially take this, and if we look at rect, we could use this as a string. Now, of course, the separator that we have, our path separator, right now, the default is a dot. So we can get that value back this way. So we have this dictionary over here, right, that has this path, but it's kind of a string. It's not an actual path we could use to query the dictionary. We had to change, right? I had to change this dimensions/length to a dimensions.length. Well, you can actually ask Benedict to give you all the different paths in this dictionary. And it's very simple. We just use the key paths. And you can see we get all the paths, but now the paths are using this center x. So I technically could do this. I could say for path in rect.keypaths, right? So I'm going to take that, and then what I'm going to do is I'm going to print, and I'll print path, and we'll print an equal sign, and then we'll print, and I'm going to take rect, and I'm going to just pass it key path, right? Which is that path that we're going to get here, center, center x, and so on. So I could do that, and I should say it's called path. And you can see we've basically iterated through all the paths in the dictionary. So as you can see, some really, really useful tools to iterate through dictionaries, to search through dictionaries, to filter dictionaries, and so on. Now we can even have it report back on every index from an iterable. If we go back and look at people again, what we had, people.results in particular, right, which was that list of dictionaries. You can see that results is itself, of course, a list, right, of these Benedicts. And then they themselves, like starships, right, is itself a list of strings and so on. So if we just do the key paths for, let's say, people.results, so I'm just going to take one of those dictionaries. I'll take the first one in results, and I can say key paths. So if I do this, you can see that we have like starships and films and so on. Those are keys in that results 0 dictionary. But it doesn't really give us an indication that, hey, we have, indices that are available and possible for starships and films and so on. So what we can do, we can specify as an argument to key path, we can say indexes equals true. And when we do that, now we get not only the key itself, right, which is the key that contains the list of films, but it also gives us this string that's going to iterate through the elements of films. So there were 4 films in that case, 2 starships, 2 vehicles, and so on. All right, so that's all I'm going to say on that library. I find it very, very interesting, and it's well written, it's well documented. Everything's in the notebook, in the GitHub repo that's linked below, including the link to where you can find that library and its documentation. So try it, give it a try in your project. If you have a need for dealing with dictionaries and doing this kind of work, just give it a shot and see what you think. I'd be interested to know, if you do use it, what your thoughts were. So please leave a comment and let me know. All right, thanks for watching, and I'll see you next time.